A raging success, Point Pleasant Park's transformation after Hurricane Juan.
Hurricane Juan hit Point Pleasant Park on September 28th and 29th in 2003, uprooting thousands of trees and dramatically changing the landscape of the park. Since 2003, there's been extensive research done about how it is rebuilding after the hurricane. With lots of research done both pre and post-hurricane, there's lots of data that points towards how well the park is doing following Hurricane Juan. Point Pleasant Park is known as Amntu'kati, or Spirit Place by Nova Scotia's Mi'kmaq. The Mi'kmaq were some of the first people to use the park to hunt, fish, and as a holding place for traditional ceremonies. It has also been found that Point Pleasant Park was not only used for the previously stated activities, but also where the spring feast ceremonies would be held, and it is a burial ground for Mi'kmaq figures of higher authority along with other associates. Point Pleasant Park can be seen as a mixed Acadian or mixed forest. Being a mixed forest constitutes being composed of red spruce and white pine, with little amounts of red maple, balsam fir, and paper birch. Within having a diverse tree range, the park also contains the unique underlying geology. The geology includes having a pyritic slate, schist, and magmatic rock types. The soil is shallow, shaly loam with strong leaching action and is very acidic, with a pH of 3.5 to 3.9. It also includes some podzolic and brown shaly loam soil types as well. The objective of our project was to measure the succession in Point Pleasant Park after Hurricane Juan through a series of research experiments. Some key words found throughout the presentation are DBH, diameter at breast height, snag, which means dead tree, pioneer species, which is the initial species of early successional to persist after a disturbance, and PPP, which means Point Pleasant Park. What is succession? Overall, succession is the gradual community change in an area following a disturbance. Primary succession is the process of succession that occurs in an area that has never been colonized. An example being, a pioneer species will gradually create soil through decomposition. Secondary succession occurs in an area that was previously inhabited but has undergone a disturbance. Soil is already present and allows for a faster recolonization by species is an example of secondary succession. We aim to answer 3 research questions throughout the duration of our experiment. Research question 1 asked how has the overall forest community changed over time and why? And what can you predict will happen to the overall community as the forest moves towards its community climax and why? Research question 2 asked how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time and why? What can you predict will happen to the dominant species as the forest moves towards its community climax and why? Research question 3 asked how has the chosen community metric changed over time and why? And what can you predict will happen to the chosen community metric as the forest moves towards its climax community and why?
The study site for our experiment was Point Pleasant Park, located in the south end of Halifax, Nova Scotia. There were 6 study sites measuring 20 meters by 20 meters that were interspersed around the park. The sites were chosen to ensure an unbiased, thorough cover of the park while observing parts that were heavily affected by Hurricane Juan. All living trees greater than or equal to 2.5 centimeters diameter at breast height were identified and measured using a tape measure in each of the 6 sites. Following the collection of the data, linear regressions were used to analyze and address our research questions. All analysis was performed using data collected from the same 6 plots every year from 2004 to 2023, excluding 2005, 2007, and 2020. Linear regression was chosen as our form of data analysis as we were interested in analyzing the straight line relationship of one dependent variable, either density or abundance, in relation to the time following the hurricane. We used a linear regression to examine the total density of Point Pleasant Park before and after Hurricane Juan in 2003. There was a significant positive relationship between the total density of the park and the time following the hurricane, with the R-squared value being 0.54, the F statistic with degrees of freedom of 1 and 79 was 95.5, and the p-value was 3.10 times 10 to the negative 15. The regression equation was total density is equal to 9.9554 multiplied by the year minus 19,971 as seen in Figure 1. There was an approximate increase of 34.4% in density from 2004 to 2023. Based on this data, we reject our null hypothesis that there would be no relationship between the total density and the year since the hurricane. As stated by Moles and Larson, during succession, the entire structure of a community is altered. Because of this, as the park community recovered from the hurricane, species began to reestablish an increase in density compared to the time of the hurricane, when 70% of the vegetation was eradicated. As Burley et al. Found, urban forests are still able to follow natural successional trends following devastating disturbances. These natural trends include an increase in density from the time of the disaster. However, in a study by Turchin, it was suggested that due to competition for resources, the density of the park is expected to diminish over time. Based on both of these findings, it can be assumed that as Point Pleasant approaches its climax, the overall community will continue to increase in density before it eventually begins to decline due to competition.
When looking at the secondary succession of the dominant species in Point Pleasant Park, we used a linear regression to examine the change of density of the red spruce and the red maple from 2004 to 2023. There was a significant positive relationship between the density of the red spruce and the time following the hurricane, which was by 5.59%. The F statistic with 1 in 79 degrees of freedom was 9.8, with a p-value of 0.002. There was also a significant positive relationship between the density of the red maple and the time following the hurricane, which was by 32.35%. The F statistic with 1 in 79 degrees of freedom was 16.8, with a p-value of 0.0001. Based on this data, we reject our null hypothesis that there is no relationship between the density of the dominant species and the years after the hurricane. The main source of density changes of the dominant species in Point Pleasant Park, red spruce and red maple, are from natural disturbances like hurricanes and cyclones. Hurricane Juan in 2003 being one of the most impactful, which removed over 70% of the overall canopy. Another stressor that only affects the red spruce is the bark beetle, which led to the removal of many snags in the park and contributed to a decrease in population size, seen in Figure 5.1. Regeneration of the red maple can be from not only seeds but also by producing sprouts from tree stumps. Over time, as the red maple were established as an even-age regenerated forest, it indicated their early succession rates and fast growth post-disturbances, seen in Figure 5.2. Gradually, as the forest moves towards its climax community, we would suspect the population to change due to the large establishments of the pioneer species red maple. Fewer of these will survive due to intraspecific competition and the law of the minimum when considering resource uptake. Wood from the red maple is not very strong or hard, which can make it susceptible to future natural disasters due to the even-age growth and lack of species richness. Later successional species better suited for the environmental conditions will eventually establish a population, although the presence of species with higher shade tolerance and nearby seed sources will be the underlying factors of regeneration. To enhance resistance against pests and future storms, a diverse population and age structure is essential to minimize gaps in the canopy and preserve the Acadian forest ecosystem.
Using linear regression to analyze how both species richness and Shannon diversity changed after Hurricane Juan in 2003, we can see that both figures show a positive relationship. In Figure 7.1, we see the positive relationship of species richness in the years following Hurricane Juan with an R-squared value of 0.64, an F statistic value of 141.6, and a p-value of 2.2 times 10 to the power of negative 16. The regression equation for species richness is 0.59 times time minus 1,180.9. In Figure 7.2, the positive relationship between Shannon diversity and the years following Hurricane Juan can be seen with the R-squared value of 0.36, an F statistic value of 40.3, and a p-value of 1.6 times 10 to the power of negative 8. The linear regression equation for Shannon diversity is 0.069 times time minus 136.8. With all this information, it is determined that we reject our null hypothesis, which states that there is no relationship between species richness and Shannon diversity and the years following Hurricane Juan. We can see that both community metrics help to reach the community climax. This is when populations hit the succession endpoint. Based off of previous research, we can analyze that this can be done from the results of a study done by Burley, Robinson, and Lundholm, which states that urban forests like Point Pleasant it is possible that after a catastrophic disturbance, these forests can show natural succession trajectories. Considering previous relationships, we can determine that the species richness and Shannon diversity of Point Pleasant Park will increase as the population moves towards community climax.
Research from Josham shows that in 1992, the Acadian forest in Point Pleasant Park was close to its community climax. Unfortunately, after the 2003 hurricane, the park was no longer near its climax and lost more than half of its canopy. Over time, urban park succession can be affected by many factors, some being anthropogenic, like higher concentration of CO2 from cars in the city and other polluters that cause stress on the trees, or interference of the natural nutrient cycling by the removal of deadwood, but are not limited to this, since it was found that the abundance of squirrels in Point Pleasant Park also affects succession by eating seeds needed to regenerate different species in the forest and increase richness. Disturbances are needed to diversify the community, to open up the canopy and allow later successional species to establish and remove competition pressure. Since 2008, over 100,000 trees have been replanted with intentions of restoring the Acadian mixed forest. It is known that the Mi'kmaq people and all other indigenous have a special relationship to the environment and especially trees. Two-eyed seeing is a term that explains the difference between the indigenous perspective and the Western colonial perspective. It is a process that is heavily reliant on research, planning, and asking permission before taking action. The second eye is emphasized as looking again or re-researching through traditional knowledge from their community. The Mi'kmaq worldview is one of interconnectedness and all that is done with the environment and sustainability in mind. The Mi'kmaq see themselves as one with the ecological community, which is something the colonial view needs to keep into consideration when dealing with these communities, through processes of truly understanding the land and ecosystem prior to taking action on the land. We would like to acknowledge the land that we are on, and the Mi'kmaq people who cared for this land before and after us. We are all treaty people. We would like to thank Dr. Allison Schmidt for all the hard work she put into creating this experiment and for supplying us with the data needed to create this project, and for our DM, Peter McGregor, for the feedback and assistance during the evaluation. We would also like to acknowledge the past ecology students from prior years who collected the data over the span of many years that we used and analyzed, and our peers from the ecology class for the helpful critiques we applied to improve our presentation. Now, to answer some questions. To effectively answer this question, we must understand that through the emissions release with CO2 are other pollutants that affect all parts of our ecosystem, which are more abundant in urban areas as opposed to rural areas due to the increased abundance of cars, industrialization, and development. These pollutants, including particulate matter, also known as PM2.5 and PM10, are mixtures of solids and aerosols with a diameter of 10 microns or less and are easily inhalable into the lungs. The increase in PM2.5 from CO2 concentrations causes the stomata on the leaves to close due to the accumulation of particulate matter and negatively affects tree growth rates. The trees are unable to respire. This causes the leaves to change the way they interact with sunlight by reducing light availability and gas exchange required to photosynthesize. While rising atmospheric CO2 has a positive effect on tree growth rate due to increased photosynthesis and water use efficiency, warming-induced stress caused by the increase of CO2, the greenhouse effect, and the urban heat island effect causes a decline in growth. Increased levels of CO2 could potentially alter tree-soil interactions, which may affect the future ecosystem's productivity. Elevated CO2 concentrations will accelerate nutrients depletion within the soil as time goes on.
When asked to answer how the succession of Point Pleasant Park would change depending on the amount of human intervention there are a few factors that have to be considered. In some cases, succession can be positively affected by human interference, such as when recovery plans are implemented. However, in certain cases, human interference could be the cause of forest succession, like an out-of-hand forest fire, for example. If there were no humans to help replant the trees that were destroyed in Hurricane Juan, the park would likely still continue on its path of succession, the same as it would with human assistance. As stated by Malley et al., forests typically recover naturally by means of passive restoration, but their rate of recovery can be amplified by human intervention. With that in mind, it can be assumed that it would take far longer for the forest to reach its climax community without the assistance of tree planting.
The third question we were asked to answer asked, How do you think a similar disturbance would impact Point Pleasant Park at its current successional stage? Would the changes be the same, and if not, how would they differ? We think that something similar to Hurricane Juan would cause the same amount of damage, if not more. Hurricane Juan made landfall as a Category 2 hurricane, which at the time was a strong hurricane and was rare for Nova Scotia. With the way that climate change is causing change on our environment, a Category 2 hurricane could become even more common these days. According to research done by NASA, an increase in climate change means not only are sea levels rising, it is also causing rougher storm surge within hurricanes. With a place like Point Pleasant Park being so close to the water and part of its edge being on the ocean, a rougher storm surge could cause more damage than what Hurricane Juan did.